Hello, in this video I'm going to discuss how to connect to EC2 using Session Manager, which is a feature of AWS Systems Manager. This is part 4 of how do I connect to my EC2 series. In this video, I'll start with a quick demonstration, then go through the steps to build the solution. I will conclude with pros and cons of using the Session Manager and discuss some alternatives that you may want to consider. You can jump ahead to any sections of this video using the chapter links in the description. Some of the main advantages of using Session Manager is that it does not require opening inbound ports such as port 22 for SSH. You also don't need a private key file or username and password to authenticate. Instead, it uses IAM permission to control who can connect to your EC2. It works for both Linux and Windows servers. If your EC2 is inside a private subnet, meaning it doesn't have a public IP address or access to the internet via the internet gateway, you can still connect using the Session Manager through VPC Endpoint. This makes Session Manager a secure and scalable solution to connect to your EC2. But there's a catch. Each EC2 requires a Systems Manager agent to be installed. So let's dive in to see how Session Manager works, and you can decide if this is the right solution for you. To get started, let's begin with a quick demonstration. Here I have an EC2 instance named Demo Public Linux in the US West 2 Oregon region. With this EC2 selected, I'll click on the Connect button. Here I have multiple options, but I've selected the Session Manager. I'll click on the Connect button. And now I'm connected within my browser. Another way to connect is using the Systems Manager. Here I'm on the Systems Manager homepage, and one of the tools is Session Manager. From here I can click on Start Session, and my Demo Public Linux is listed as one of the target instances. I'll select that and click on Start Session, and I'm connected again. Another way is using Fleet Manager. Here in my Fleet Manager page, I see that Demo Public Linux is listed as one of the managed nodes. I'll select it, go to Node Actions, Connect, Start Terminal Session, and connect it again. The last method I'll show you is using the AWS CLI. So here I'm on the terminal application. I have the AWS CLI already installed. I will issue this command ssm start session with the target parameter value equal to my instance ID. And now I'm connected within my terminal application. So those are 4 different methods of connecting to your EC2 using Session Manager. Notice when I connected in all these methods, I didn't have to provide any private key file or some other credential. It simply connected right in my browser or terminal application. You can also connect to your Windows servers using Session Manager. Now that you've seen how to use Session Manager, let's look under the hood to see how this works. Here I have an architecture diagram of connecting to a Linux EC2 inside a public subnet using Session Manager. I will explain each component and show you how to build this yourself. By the way, if you want to get this diagram and steps to build this solution, see the links in the description of this video. There are 2 use cases we will build using Session Manager. First is connecting to an EC2 inside a public subnet from the internet using either AWS Console or AWS CLI. Second is connecting to an EC2 inside a private subnet using the Session Manager with VPC Endpoint. Let's start with the first use case, which is to connect to a Linux EC2 inside a public subnet from the internet. For this use case, we will use an IAM user named Brian, who will connect first using the EC2 console, then connect again using the AWS CLI from his laptop. Before I launch my EC2 instance, I need to configure several networking components. So let's go over to the AWS console to build a solution. For this demonstration, I'm logged into the AWS console as an IAM user named Stuzio admin. In the IAM user page, you can see that this user has administrator access permission, so I am able to create just about any resource in this account. So the first step is create the virtual private cloud VPC and the subnet. On my console, I'm on the VPC dashboard. I'll click on the Create VPC. I'll use a VPC only option. I'll name my VPC Demo VPC. For the CIDR, I will enter 10.0.0.0/16. I'll leave everything else as default and click on Create VPC. Before I move on, I'm going to enable the DNS hostname. Notice that currently the DNS hostname is disabled. So I'll go to Action, Edit VPC Settings, check the Enable DNS hostname. If you enable this setting, then your EC2 will get assigned a public DNS name that we can use to reference it from the internet, like a public IP address. Note that for this Session Manager solution, both Enable DNS hostname and DNS resolution is required. So make sure that both of these are checked in your VPC. Next, I'll create the subnet. Click Create Subnet, and I'll select my VPC. In this case, the demo VPC that I just created. I'll name this subnet Demo Public Subnet. I'll leave the availability zone as no preference because it doesn't matter for this demonstration. For the subnet CIDR block, I'll enter 10.0.0.0/24, which is a subset of the CIDR block of my VPC. I'll leave everything else default and click on Create Subnet. The next step is to create the Internet Gateway and the route table. The purpose of this component is to create a networking route so I can connect to the EC2 from the public internet. So I'll click on Internet Gateway, Create Internet Gateway. I'll name my gateway Demo Internet Gateway. Notice that the state is currently detached, so I have to attach this to my VPC. I'll go to Attach to VPC and select my demo VPC and click on Attach Internet Gateway. The next thing I'll create is a route table. Just because we have the Internet Gateway doesn't mean any traffic will be routed to it. We need a route table that instructs the subnet what traffic should be routed to the Internet Gateway. So I'll click on Create Route Table, and I'll name this route table Demo Public Route Table. And for VPC again, I will select the demo VPC. Create route table. Notice that the route table has the default route for the local. We need to add a route for the Internet Gateway. I'll click on Edit Routes, Add Routes. For destination, I'll select 0/0, which is all Internet. For target, I'll select Internet Gateway and my Internet Gateway Demo Internet Gateway instance. Click on Save Changes. Okay, so now I have two routes on this route table. I now want to associate this route table to my subnet. I'll click on Subnet Association, Edit Subnet Association, click on my Demo Public Subnet. So now I have a route table associated with my subnet that instructs all destinations other than the local VPC CIDR should be routed to the Internet Gateway. The last step for networking is to create a security group. Security group is a type of firewall that controls what type of inbound and outbound traffic will be allowed for my EC2. For Session Manager to work, the Systems Manager agent on the EC2 needs to make an outbound connection using HTTPS protocol to the following three public endpoints within the AWS region where the EC2 resides. AWS does not provide a managed prefix for these endpoints, so we'll just specify 0/0, which is all internet, to cover the public IP addresses for these endpoints. Note that we don't need to specify an inbound rule such as port 22 for SSH. This is one of the main advantages of using Session Manager. So I'm on my VPC dashboard page. I'll scroll down and click on Security Groups. Create Security Groups. I'll name this security group Demo SSM Security Group. For VPC, I'll select Demo VPC. I don't need any inbound rule. There is one default outbound rule that's already been added. I'm going to delete this and add a new one. For the type, I'll select HTTPS. Notice that when I select this, the protocol and port range is automatically selected. For destination, I'll select Anywhere IPv4. Notice that this sets the value for 0/0, which is all internet. This essentially covers all the IP addresses for the three services that we need to connect to. Now I'll click Create Security Group. So now I have this security group with no inbound rule and one outbound rule. The last step before launching our EC2 is an IAM role that our EC2 can assume using Instance Profile. Recall that an Instance Profile is a feature of EC2 where you can specify an IAM role. Within an IAM role, we can attach one or more permissions. So in our case, For the SSM agent to work, it needs certain permissions to interact with the three service endpoints, namely the SSM, SSM messages, and EC2 messages. The way we're going to provide the necessary permission is through a role I created named SSM Demo EC2 role. So here I'm on the IAM dashboard. I'll go to the roles, and here I have a role called SSM Demo EC2 role. Inside this role, there's one permission named Amazon SSM Managed Instance Core. This is a permission that AWS manages, and it contains several allow statements that SSM agents need in order to provide its connection. Keep in mind that if your EC2 already has a role in the instance profile, then you'll need to add the permissions for SSM into a single role. That's because EC2 instance profile can only contain one IAM role, but an IAM role can contain multiple permissions. Now that we have all the networking pieces, we are ready to launch our Linux EC2. This is going to be inside our demo public subnet using the demo SSM security group we created. So here I am on the EC2 homepage. I'll click on Launch Instance. I'll name this Demo Public Linux. For Application OS image, I will select Amazon Linux and Amazon Linux 2023 AMI. AMI stands for Amazon Machine Image, which is an image that provides the software needed to boot an Amazon EC2 instance. The image you choose here is important because in order for Session Manager to work, it needs a software called System Manager Agent running on it. By selecting the Amazon Linux 2023 AMI, I know that SSM agent is already installed on my EC2. If your server does not have an SSM agent installed, then you need to first install it. You can find all the AMIs with SSM agents pre-installed and all other requirements in the SSM documentation. Just remember that for SSM to work, the System Manager agent must be installed and running. For instance type, I'll leave it as T2 Micro. For key pair, I'm going to proceed without key pair. For the purpose of connecting to EC2 using Session Manager, we don't need this key pair. This is one of the main advantages of using Session Manager, which uses an IAM credential to authenticate. For networking, I'll click on Edit. For VPC, I'll select Demo VPC. For Subnet, I'll select Demo Public Subnet. For Auto-Assign Public IP, I'm going to enable this. The public IP is required in this case because our EC2 inside a public subnet needs to connect to the three public AWS endpoints. This is not for the end user to reference the EC2 from the console or CLI over the internet. For firewall, I'll select Existing Security Group and select Demo SSM Security Group. The one last thing I need to do is configure the instance profile. For that, I'll go to Advanced Details. For the IAM instance profile, I'll select the SSM Demo EC2 role that we created earlier. Recall that this is a role that contains the permission that our SSM agents will need in order to interact with the three AWS services. With that, I'll click on Launch Instance. Let's go look at the details. Now my EC2 is ready for use. Now that my EC2 is launched, let's test connecting it using Session Manager. One of the easiest way is to go to the EC2 service, select the EC2 and click on the Connect button. I'll go to the Session Manager option, and if everything is configured correctly, you should see the Connect button enabled. And I'll just click on the Connect button. And now you're connected. Now recall that I'm currently logged in to AWS console as Stuzio Admin User who has an administrator permission. What happens if I log in as Brian IAM User and try to connect to this EC2 using SSM? If I look at user Brian, I can see that currently he has no permission. Therefore, he won't be able to do anything. In order to grant him permission to connect to EC2 using SSM, he will need a set of permission. So let's add a permission for Brian. I'm going to attach policy directly. And I'm going to attach a policy called Demo Session Manager User Policy. This is just a custom permission I created that allows the user to connect to EC2 using Session Manager, Fleet Manager, and EC2, as well as AWS CLI. So I'll click on Next, Add Permission. Let's look at this policy. Note that you can enhance this statement by adding conditions, but for this demo, I only have resource limited to the US West 2 region and current AWS account. If you want to use this permission, be sure to update this resource statement with your region and account number. So with that, let's log in as Brian. I'll use the handy multi-session feature. Okay, now I'm logged in as Brian, IAM user. Let's go to EC2. I see the demo public Linux. I can select that. While I can't do a lot with this EC2, I should be able to connect using SSM. So I'll go ahead and click on Connect button. Under Session Manager, I'll click on the Connect button. And Brian is now connected. Brian should also be able to connect using Session Manager. Here I am on the AWS System Manager in the Session Manager tool page. I'll click on Start Session. Again, I see my demo public Linux target instance. I'll select that and click on Start Session. And it's the same experience. I'm connected again. Another path is using the Fleet Manager. I'll click on Fleet Manager. And I see my demo public Linux as a managed node under Fleet Manager. I can select this node, go to Node Action, Connect, Start Terminal Session. And this will give you the same connection. The last option is connecting to this EC2 through Session Manager using AWS CLI. So for that, let's go back to our EC2 page. So I'm going to open the terminal application. And I already have the AWS CLI installed. And on my machine, inside the AWS credentials file, I have Brian's access key and secret key already configured. So when I issue the AWS CLI command, I'm using Brian IAM user credential. So the command I'm going to use is SSM start session. And one of the parameters I need to enter is the target. And the value for this target is the instance ID of my demo public Linux EC2. And I can get that from the EC2 details page. And I'll issue this command now. And now I'm connected again. Notice that when Brian issues this SSM start session command, the target is instance ID, not the public IP address of the demo public Linux instance. Also, Brian didn't need to provide any additional credentials like a key file or username and password. Instead, SSM used Brian's IAM credential to authenticate and his permission to authorize. The next use case is to connect to EC2 inside a private subnet using Session Manager. A private subnet here simply means the EC2 instance inside doesn't have a route to the internet. These may be your database or application servers that you don't want to expose to the internet. Recall in our previous use case with the public subnet, the EC2 was assigned a public IP address and there was a route to the internet via the internet gateway to the Systems Manager service. So if the EC2 inside a private subnet doesn't have a route to the internet to reach the SSM public endpoints, how can it work? The answer is VPC Endpoint powered by AWS Private Link. This allows EC2 inside your VPC to privately connect to AWS Systems Manager service without an internet gateway or public IP address. Basically, a VPC endpoint is made up of one or more elastic network interface with a private IP address of your subnet and is connected to AWS service endpoints through a private network. Thus, the traffic between the EC2 inside your subnet and AWS service traverses through AWS's private network and does not go through the internet. For our use case, the EC2 needs to communicate with 3 different AWS service endpoints in the US West 2 region for Session Manager to work. Notice that these are just public domain names for regional AWS service, which resolves to some public IP address. But now, our EC2 can reach them through VPC Endpoint using a private IP address. When using VPC Endpoint, there are a few things to keep in mind. First, one VPC endpoint can be configured to just one service endpoint. In our case, since there are 3 different service endpoints, we will need 3 VPC endpoints, each representing private connection to 3 different service endpoints. Second is that elastic network interface that's launched by VPC Endpoint into your subnet requires a security group that controls what traffic can come in and out of the ENI. In our case, the SSM agent in the EC2 initiates the connection from the EC2 to the session manager via TCP port 443. This means that the security group for the VPC endpoints needs to allow inbound traffic from EC2 on TCP port 443. Likewise, the security group for the EC2 needs to allow outbound traffic to the 3 VPC endpoints. Remember, the security group rules are stateful, so we don't need rules for response traffic. Finally, there is a cost for each VPC endpoint in terms of flat hourly rate and per amount of data processed. So keep these points in mind when using VPC Endpoint. Now that we understand the concept, let's build these components. The first step is to build our private subnet. So here I am back on the VPC dashboard, and I'm going to reuse the demo VPC that we built earlier. So I'll go to Subnets, Create Subnet. For VPC, I'll select Demo VPC. I'll name this subnet Demo Private Subnet. For availability zone, I'll leave it no preference. For the subnet CIDR block, I'll enter 10.0.1.0/24, which is a subset of my VPC CIDR block. I'll leave rest as default and create subnet. Next, I'll create a route table. Create route table. I'll name this Demo Private Route Table. For VPC, I'll select Demo VPC. Create route table. This has one route for the local, and since this is a private subnet, this is all I need. Next, I'll associate this to the subnet. Edit subnet association. Select Demo Private Subnet that we just created. Save association. So now I have a private subnet and a route table. Now we're going to create 2 new security groups, one for the EC2 and another for the VPC Endpoint Interface Network that controls what traffic is allowed. Let's start with the EC2. Here I'm back on the VPC dashboard. I'll scroll down to Security and go to Security Groups. Create Security Group. Let's start with the security group for our EC2. I'll name this SSM EC2 Private Security Group. For VPC, I'll select Demo VPC. I don't need any inbound rule, but I do need an outbound rule. There are several ways to configure the outbound rule, but I want to use the security group as a reference to get away from CIDR block or IP address. So for now, I'm going to delete this default outbound rule. And I'm going to create the security group without any rules for now. We'll come back to this. Let's go back to our security groups. And now let's create a security group for our VPC endpoint. I'll name this SSM VPC Endpoint Security Group. For VPC, I'll select Demo VPC. For the rule, I'm going to delete this outbound rule, and I'm going to add a new inbound rule. For type, I'll select HTTPS. And for source, I'll select custom. And here, I'll select the security group, namely the SSM EC2 private security group that we just created. So what we're saying here is we want to allow HTTPS traffic from any instance with the SSM EC2 private security group. I'll create security group. Let's go back to our security groups. Now let's go back and edit the EC2 private security group. Here we need an outbound rule. Edit outbound rules, add rule. Type is HTTPS. And for destination, I want to allow outbound traffic to the SSM VPC Endpoint Security Group, which will be used for the VPC Endpoint ENI. Save rules. So now we have our 2 security groups, one for the EC2 and another for the VPC Endpoint. Now that we have the subnet and the security group created, we're now ready to create the 3 VPC endpoints. So here I am on the VPC dashboard. I'll scroll down to Endpoints. Create Endpoint. I'll name the first one SSM Endpoint. I'll leave the type as AWS Services. For service, I'll select SSM. This is the SSM service for my US West 2 region. For network settings VPC, I'll select my demo VPC. For DNS name, I'm going to leave Enable DNS name. This creates a private DNS entry such that anytime a resource like our SSM agent calls the public AWS service endpoint, in this case, com.amazonaws.uswest2.ssm, it gets a private IP address of the VPC endpoint. In order to use this, you have to make sure that both DNS hostname and DNS resolutions are enabled in your VPC. Enabling this has ramifications for all resources that's connecting to SSM within your VPC, such as those you created in the public subnet that wasn't intended to use the VPC endpoint. We will come back to this later. The next thing I have to do is select the subnets. Here you can select multiple subnets, or more accurately, multiple availability zones. If you have multiple subnets that cover multiple availability zones, you can select more than one here. If you do, an interface endpoint will be deployed to each subnet you specify in the availability zone, thus providing you better resilience in case of an AZ failure. In our case, both of our subnets are in the same availability zone, so I'll just select Demo Private Subnet. I could choose the public subnet and it'll still work. Whichever one you select, you just have to make sure that the security group allows necessary traffic. In our case, the security groups use the security group as a reference rather than IP address or CIDR block for the source and destination, so either one I select here will work. For security group, I'll select the Demo VPC Endpoint security group that we created earlier. I'll leave everything else as default, create endpoint. Now I'm going to repeat these 2 more times for the other 2 VPC endpoint that we will need. So create endpoint, I'll name this SSM message endpoint. Again, I'll select demo VPC, leave the enable DNS name. Subnet, I'll select demo private subnet. Security group, VPC endpoint security group. Create endpoint. And one last time, create endpoint. I'll name this EC2 message endpoint. I'll select EC2 message endpoint service name. VPC demo VPC. Demo private subnet. For security group, VPC endpoint security group. Create endpoint. This may take a few minutes. Now all my 3 endpoints are available for use. The last step before testing our SSM with VPC endpoint is to launch our EC2 inside a private subnet. So here I am on the EC2 page. I'll click on Launch Instance. I'll name this Demo Private Linux. For AMI, I'll leave it as Amazon Linux 2023. Instance type, I'll leave it as T2 Micro. For key pair, I'll select Proceed without key pair. Similar to our public subnet use case, we don't need a key pair for the purpose of connecting to this EC2 using SSM. For network setting, I'll click on Edit. VPC, I'll select Demo VPC. For subnet, I'll select Demo Private Subnet. For auto-assign public IP address, I will disable it. Recall that this is designed to be a private EC2 instance without access to the internet, so I don't need a public IP address. For security group, I'll select Existing Security Group, and I'll select the SSM EC2 Private Security Group. One last step, I'll go to Advanced Detail and select my IAM instance profile, the SSM Demo EC2 role. And now I'll launch instance. Now my Demo Private Linux is ready for use. Now it's time to test our session manager with VPC endpoint in a private subnet. We have all the components launched. So here I am on the AWS console, logged in as Brian IAM User. I'm on the EC2 instance page and I have Demo Private Linux selected. I'll click on Connect. I'll click on Connect. And now I'm connected. Just word of caution, I noticed that in some cases this connection is quite slow. In my case, in the US West 2 region, it took almost 3 minutes before the prompt came up. If you experience consistent slowness using the solution with VPC Endpoint, you may want to work with AWS support. But in any case, it did come up and it's working. I can also connect using the AWS CLI. Here I have my demo private Linux instance ID as a target value. And now it's connected. Again, it took almost 3 minutes for this to connect. When this occurs, and I try to deploy this in a different region, it's quite snappy. So this may be related to a region. As before, Brian can also make the same connection from the session manager as well as the fleet manager. So this demonstrates that you can connect to an EC2 instance inside of private subnet using session manager with VPC Endpoint. Now that we have the private EC2 all working, let's go back to our public subnet EC2, our demo public Linux, and see if we can connect to it again using session manager. So I'll select demo public Linux, and I'll go to connect button. Notice that now in the session manager option, it says that SSM agent is not online and my connect button is disabled. Recall that in our first use case, this was working fine. And now that we have VPC endpoints deployed into a private subnet, it broke our public subnet session manager. Why? The reason is that when we created the VPC endpoint, we enabled a DNS name which created a private DNS which affects the entire VPC. So now, when our SSM agent inside the demo public Linux tries to call any of the 3 AWS services, it gets the private IP address of our VPC endpoint rather than the public IP address as before. However, our security group does not currently allow this traffic pattern, so we have to alter our security group. So let's go back to our VPC, security groups. Let's start with our security group for VPC endpoint, the SSM VPC endpoint security group. Currently, it only allows inbound HTTPS traffic from the SSM EC2 private security group. We need to now allow the same inbound traffic from the demo public Linux EC2. We can do this by adding a new inbound rule that specifies the source as the security group of the demo public Linux, which in this case is demo SSM security group. So I'll click on edit inbound. I'll add a new rule. For the source, I'll select demo SSM security group. This is the security group that our demo public Linux instance is using. Save rule. Now, our VPC endpoint security group allows inbound traffic from both security groups, namely the inbound from private and public subnet EC2 instances. Now this should work as is, but let's go back and edit our demo SSM security group. I'll go to the outbound rules and edit outbound rules. Recall that in our public subnet use case, we specified all internet in order to cover the public IP address of the 3 service endpoints. Now that we're going to utilize the VPC endpoint private IP addresses, we can actually delete this and tighten up this rule. So I'll go ahead and delete this, add rule, and for destination, I'll select the VPC endpoint security group. It's always good practice to tighten up the security group rules. I'll click on Save Rules. Okay, so now we've edited the outbound rule for demo SSM security group. Let's go back to our EC2. Here I am logged in as Brian again. I'll select the demo public Linux and click on Connect. Now right away, I get this error that instance is not connecting to the session manager. I'll go ahead and refresh this page. And now the connect button is enabled. In some cases, you may have to wait a little bit or reboot your EC2 instance. So let's go ahead and try to connect again. And now it's connected. So Brian is now able to successfully connect to both demo private Linux inside a private subnet and demo public Linux inside a public subnet. Just remember, when you deploy VPC endpoints for SSM with enabled DNS, it'll impact all SSM connections in your VPC, regardless of the subnets. So, is Session Manager the right solution for you? It certainly has its advantages, namely, the fact that you don't need a private key file or separate credentials to connect to your EC2. It just uses your IAM credentials. Another advantage is that it doesn't require you to open network ports such as 22 for SSH. It works for both Linux and Windows servers. You can even connect to nodes in a private subnet using VPC Endpoint. This is a big security advantage. As a bonus, Session Manager is free. One downside of Session Manager is that every node you connect to must have a SSM agent installed. This poses some limitations due to its compatibility and additional steps to install it on your node if it doesn't already exist. Another additional step is to add a role with Session Manager related permissions through instance profile of your EC2. This means every time you launch an EC2, you have to make sure the right permissions are included. This could be burdensome in large organizations where thousands of EC2s are being launched by many teams. Also, what if you want a centralized way to connect your EC2, but people launching the EC2 don't follow all the steps necessary for Session Manager? This is where Fleet Manager may be a better solution. If you're interested in learning more about how Fleet Manager can help you centralize connecting to EC2 at scale, then watch the Connecting to EC2 using Fleet Manager video. Well, I hope you found this video useful. Thank you for watching and keep on building.